Here, the circuit contains only dependent sources. That changes the question. There is no independent source that can create a definite open circuit voltage by itself, so we do not start by hunting for Thevenin. Instead, we measure the resistance seen from terminals A and B. The clean way is to attach a test source at the port. In these two examples, we will inject 1 ampere from B to A, compute the resulting terminal voltage, and then use R Thevenin equals V test divided by I test. Example 1 has a dependent voltage source equal to 1.5 volt 1. The voltage V1 is across the right 6 ohm resistor, with plus on the left and minus on the terminal aside. The port is still A and B. Since the network has no independent source, the target is only R Thevenin seen at a B. We connect a 1 ampere test source upward from B to A and call the port voltage Vy. Now slow down and define the node voltages. Let the middle top node be Vx, because the 6 ohm resistor on the right has voltage V1 from left to right, and the port node is Vy. We have V1 equals Vx minus Vy. The same statement can be written as Vx equals V1 plus Vy. That substitution keeps the dependent source and every resistor current consistent. Write KCL at the middle top node first. The current through 4 ohms is Vx minus 1.5 Vt1 all over 4. The current down through the middle 6 ohms is Vx over 6. The current through the right 6 ohms is Vx minus Vy over 6, which is V1 over 6. Substitute Vx equals V1 plus Vy. After multiplying by 12, the equation becomes 5Vy plus 2.5 V1 equals 0, so Vy equals negative 1/2 V1. Now write KCL at terminal A. Current from a back through the right 6 ohm resistor is Vy minus Vx over 6, and the 1 amp test current enters the node, so Vy minus Vx over 6 minus 1 equals 0. That gives V1 equal to negative 6 volts. Therefore, Vy is 3 volts. Since the test current is 1 ampere, R Thevenin is 3 ohms. Example 2 looks different, but the idea is the same. The dependent source is now a current source of value 2Vab, and its arrow points to the left. The port voltage Vab is positive at A and negative at B. Again, there is no independent source, so we attach the same 1 ampere test source from B to A and solve for the voltage that appears at the port. Use the top right node, which is terminal A. Let Vx equal Vab. Current down through the 2 ohm resistor is Vx over 2. The dependent current source sends 2 Vab away from this node toward the left. The 1 ampere test source enters the node. KCL is therefore Vx over 2 plus 2 Vab minus 1 equals 0. Since Vx is the same as Vab, we have Vx over 2 plus 2Vx equals 1. That is 2.5 Vx equals 1, so Vx equals 0.4 volts. With a 1 ampere test current, R Thevenin is 0.4 ohms. The takeaway is simple. When a port network has dependent sources but no independent source, do not invent a Thevenin voltage. Measure the port resistance. Keep every dependent source active, apply a test source, write KCL with the source direction included, and divide the measured port voltage by the test current. In example 1, the resistance is 3 ohms. In example 2, it is 0.4 ohms.